Hello, and welcome to Applied Mathematics for Business, CQMS 110. I am Dr. Pauline Fu. In this video, we will talk about basic algebra. Topic includes basic percentage problem, notion of variables, evaluating expressions, polynomials, monomials, binomials definitions, as well as degree of polynomials. And we focus on the operations for polynomials: addition, subtraction, multiplication, and division. Finally, we'll touch upon the topic of factorial. So the basic percentage problem, we use the formula. The formula is in two formats. One is percent equal to rate multiplied by the base. The other format is new number equal to rate multiplied by original number. For example, if you are asked, what is 15% of $20? So this 15% is the rate, and $20 is the base or original numbers. So based on this formula, you are giving the rate 15%, the base is $20. Then you multiply those two numbers, you get the result. So multiply rate by base, you get $3. $3 is the percentage. If you use the second formula, it is the same concept. So the rate is 15%, original number $20, and you get $3. Okay. So this is a basic percentage problem. In this formula, you have three items: percent, base, a rate, and a base. Any of these three items, if you are given two, you will be able to figure out the other item. For example, if you are given the percentage, you are given the rate, what is the base? Base equal to percentage divided by rate. Okay. On the other hand, if you are given the percentage, you are given the base, what is the rate? Rate equal to percentage divided by base. Okay. So this is a funding rate of increase or decrease. Question: $325 is what percent more than $200? So we are use this formula, rate of change. In numerator, you have amount of change, that is $325 minus 200, $125. That is the numerator. On the denominator, you have original number, $200. You do the division, and you get 0.625, 62.5%. So the answer is increased by 62.5% from $200 to $325. Similarly, you can do the decrease problem. It is the same principle. So this example is the decrease problem. You see, the same formula. The question is, what percent less than 200 is 180? So first, you figure out what is the amount of change. 180 minus 200 minus 20 equal. And then you use this formula. The amount of change, negative 20, divided by original number, 200, you get negative 0.1 or negative 10%. this negative means decrease. Okay, so if you decrease $200 to 180, the decrease is 10%. So this is about some terminologies about algebraic expressions. So first, what is algebraic operations? Any addition, subtraction, multiplication. Sometimes we use dot, sometimes we use this star. Okay, and division, sometimes we use this slash, sometimes we use this little bar. So those are algebraic operations. And algebraic expressions, any combination of numbers, literal symbols like X, Y, Z, or A, B, C, those are literal symbols that result from algebraic operations is algebraic expression. The next term is a term. A term is any collection of multiples that is added or subtracted in an algebraic expression. For example, 2x, that is a term. Even 2x squared, that is a term. A factor is made up of volumes that are multiplied together within a given term. Okay, for example, if you have 2 times x squared, what is the factor? 2 is a factor, x is a factor, x squared is a factor. So there are 3 factors in this algebraic expression. Next terminology, primary factors. If a factor cannot be further factored, it is a primary factor. Okay. For example, all these are primary factors because it cannot, no, these 2 are primary factors, 2 and x. Okay. Compound factors which can be further factored. For example, x squared is compound factor because it can be further factored by x multiplied by x. Okay. Polynomials. A polynomial is an algebraic expression with only non-negative integer exponents on one or more variables and has a null variable in a denominator. The degree of a term is the sum of the exponents of variables, and the degree of polynomial is the degree of the term of the highest degree. For example, if we have an expression 4x squared plus 3x plus 1, this is a polynomial. In this polynomial, we have 3 terms, 1 term, another term, still another term. Okay, and the degree of term, the degree of the first term is 2. The degree of second term is 1. The degree of the third term is 0. Okay, so this is the degree of term. So what is the degree of polynomial? So of all the degree of a term, I said before, the highest is this one. So this polynomial, the degree of this polynomial is 2. Okay. Pay attention to the definition polynomial. You only have non-negative integer components. If you have something like 1 over x, because 1 over x is the same as x raised to power -1, here you have a negative number as exponent. So this is not a polynomial. So this one is multiplication of algebraic expressions. For example, if you want to do multiplying monomials, so this is an example. What you do, you take the numerical coefficients So 4 multiplied by 3. And then you take literal coefficients. X squared is literal coefficients. X4 is literal coefficients. So multiply by, usually I use dot, x squared, then multiply by x raised to power 4. And then you simplify this expression, becomes negative 12 multiplied by x raised to power 6. Okay. Next, when you do multiplying polynomials, and you do this, the first term multiplied by this bracket, so it becomes 2x cubed multiplied by 5x squared minus 4x cubed. And then you do the second term, include the negative sign. So negative 3x raised to power 5, and then multiply by the bracket. And now it becomes monomials multiplied by a polynomial. And you multiply each item, so 2x cubed multiplied by 5x, I'll do slow, 2x cubed multiply 5x squared, and then you do 2x cubed multiplied by negative 4x cubed. So it is negative 2x cubed multiplied by 4x cubed. Similarly, you do this, negative 3x5 multiplied by 5x squared. So I'll directly give you the result. It is negative 15x raised to power 7. And then you do negative 35 raised to power 5 multiplied by negative 4x raised to power 3. So negative multiplied by negative, it is positive. 3 multiplied by 4 is 12. X raised to power 5 plus 3, 8. Okay. And then you simplify this. So this one is 10 x raised to power 5, negative 8 x raised to power 6. Okay, copy down the last two items. Okay. Finally, you see if there are some like terms to collect, no, and then you usually we arrange polynomial from the highest degree to lowest degree. So we put 12x raised to power 8 is the first, followed by 15 x raised to power 7 minus 8 x raised to power 6 plus 10 x raised to power 5. And the degree of this polynomial is 8, the highest degree of the term, okay? And there are 4 terms in this polynomial. So we talked about the multiplication. Now let's go to the division. So division by monomials divisor. So if you want to do this division, numerical coefficient divided by numerical coefficient. Literal coefficient divided by literal coefficient. And then you simplify this. It is just negative 4 over 3 negative. I already consider negative, so there is no negative here. Okay. So the result is x2 minus 4 raised to power 2 minus 4. And continue. Negative 4 over 3 x minus 4. Okay. And sometimes you can move this negative 2 to the denominator position. So it becomes 3x squared. Okay. So this is a division by monomials. If you have a numerator is a polynomial, denominator is a monomial, as this example, and you do this. You use each term in the numerator divided by denominator minus 3x raised to power 5 divided by 5x squared. And then you simplify each term. Okay, so the first one becomes 2 over 5 multiplied by x. The second is 3 over 5 multiplied by x raised to power 3. Okay. So this is the formula for special algebraic products. Those formulas are useful in the algebraic expressions, can speed up your calculation. Okay, so the distribution law, for example, 2 times x plus y, it is just equal to 2x plus 2y. Okay. And the next one, square of binomials. Okay, square of binomials. For example, 2 plus 3 raised to power square equal to 2 square plus 2 multiplied by 2 multiplied by 3 and plus 3 squared. Okay, and the result is 4 plus 12 plus 9. So the final result 25. Okay, and this is square of binomial. If you change, it could be negative sign, you use corresponding formula. The next one, product of 2 binomials. Okay, so x plus a, this one here. And this formula is also useful when you do the factorial later on. Okay, so when you do factorial, you look from right-hand side to left-hand side. Given this expression, can you write down a production? Okay. Similarly, this one here. Okay. So last one is product of sum and difference. Okay. Again, this is the basic foundation for factorial. If you take a look from right-hand side to left-hand side, from right-hand side to left-hand side. So how do you factor x squared minus y squared? It is equal to x plus y bracket times another bracket, x minus y. Okay. And similar here. Okay. So this is now the last topic, factorial. So those are the terminology, factor. Okay. If we have, I already give you examples. For example, 2x cubed. Okay. So what are the factor? You have 2 is a factor. X is a factor. X squared is a factor. X cubed is a factor. There are many factors in this expression. Okay. Factorial So if you have, for example, x squared minus y squared, this is the algebraic expression. How do we express this one in product form? Means equal to what term multiplied by what term. Okay, so we know from the formula we just learned, it is equal to x plus y multiplied by x minus y. So I already did factorial for this one. Okay, prime factor is you cannot further reduce the factor. So this is prime factor, this is prime factor because you cannot further reduce. Factor completely, when you get those production of the terms, each one is a prime factor. So the result is factored completely. Next one is GCF, stand for greatest common factor. For example, if you have AX plus AY, the greatest common factor is A. You can take A away and then multiply by X plus Y. Difference of squares, we see this formula before. Next one is factoring trinomials with a leading coefficient of 1. You based on this formula. Okay, so the important thing about this formula is coefficient of the highest term is 1. Okay, and the second, the coefficient of x is a plus b. And the same number a, b, if you multiply them together, it becomes a constant a multiply b here. Okay, so let's look at an example. Factor x squared plus 5x plus 6. Based on this formula, we need to find what is a, what is b, such that a plus b equal to 5, and a multiplied by b equal to 6. The question is, what are those a and b? Because this is a simple problem, we can use try and error, okay? But the final result, a equal to 2, b equal to 3, okay? A equal to 2, b equal to 3, or you can say a equal to 3, b equal to 2. Okay. So once you identified a and b, and this equal to x plus a is 2, multiplied by x plus b is 3. Okay. So next one, factorial, factorial general trinomials. For this one, it is a little bit complicated. So you need to recognize the characteristics of this one here. Okay, so this is x squared plus something x plus a constant. Okay, and you need to identify 4 different numbers, A, B, C, D. The way you arrange A, B, C, D, you put this way here, A, B, C, D. Once you can identify A, B, C, D, you can factor it to this result. Okay, so A multiplied by C must be the coefficient of x squared. B multiplied by D must be the constant over here. And if you do the cross production of A multiplied by D plus C multiplied by B, you get the coefficient of x here. So the coefficient of x is the cross production. Once you recognize these characteristics, let's do this problem. You are required to factor this trinomial. How do you factor this trinomial? you need to identify A, B, C, D. So to start, maybe you can try 8 is the result of A multiplied by C. So which two numbers multiplied together equal to 8? There are many possibilities. You can try each of them. So let's just try 2 multiplied by 4 is 8. Okay, 2 multiplied by 4 is 8. And next, you need to identify which two numbers multiplied together is 15. Again, there are many possibilities. Let's try 3 multiplied by 5. 3 multiplied by 5 is 15. Okay, and lastly, let's verify the cross product add together equal to 22. So 2 times 10, or 2 times 5 is 10, plus 4 times 3, 12. The result is bingo, 22. So now this arrangement is successful. Okay, so you can write down the result is 2x plus 3 multiplied by 4x plus 5. Okay. And you can verify if this is correct by using multiplication of two polynomials. Okay. So in summary, what we did in this lecture, we did a basic percentage problem. Remember, there are only 3 simple: percentage equal to base multiplied by rate. And we have a notion of variables. Evaluating of expressions, we did actually in lecture 2. Okay. We also talked about the definition of polynomial, monomial, binomial, as well as the degree of polynomials. And we did focus on the polynomial: addition, subtraction, multiplication, and the division. Finally, we touched upon the factorial. Okay, that's all for this lecture. Thanks for watching.